Guys, this is our very last lesson for the year for math. Wild to think about. What I have decided to do here in our last lesson is give you a little bit of a taste of what you will be working on next year in high school algebra. So I've jumped to section 6-2. You guys can absolutely handle this, and I don't know, I think it's one of those sections that's fairly easy, but it makes you really feel like, oh my gosh, I really get this. I've learned a lot. So what I would like you to do right now is go ahead and pause your video. I want you to make your heading for 6-2, but please do the 2 vocab words from 6-1 and the 1 vocab word from 6-2. So 3 vocab words in all, 2 from 6-1 and 1 from 6-2. And then I want you to come back to the video. All right, so our, here we go. Our heading here is 6-2, solving systems using substitutions. I did ask you to go back to 6-1 though, and grab those 2 vocab words just so you know kind of what it is we're talking about here. So the 2 vocab words from 6-1 were system of linear equation and then solution of a system of linear equation. So a system of linear equation is anytime that you have 2 or more equations that are working together. So we so far have just talked about one equation, one inequality, or one equation, and we've been able to find solutions for those. It's a pretty complex bunch. You guys have done a really good job with those. Now this is going to systems of equations. So now we're going to have 2 or more equations, or more inequalities. And we're going to be finding solutions to those. So the solution to a system of equations is when you have those 2 equations. So say we have 2 lines. Say these are our 2 lines, wherever those are on a coordinate system. The solution to that system of equations is going to be this one spot. There's going to be one order pair where those are both true. So whatever that order pair is, it's going to be a solution to this equation. So we plug it into that equation, it'll work. We plug it into this equation, it'll also work. That's what the solution of a system of equations is. It's that one spot where those lines actually intersect. Okay, so that one order pair would be a solution to both equations, which is pretty cool mathematically. Going on to 6-2 then, you have one additional vocab word, which is substitution method. This is the one way that I'm going to have time to teach you guys this year how to solve these systems of equations. And frankly, it's my favorite way to do this. You can do it a few ways, but this absolutely is my favorite. You are going to solve one of your equations. You're going to solve for either x or y, and then you're actually going to substitute that value into your other equation and solve it out. It gives you both your x and your y. We can check it in both equations to make sure it is the actual solution to that system and see, if we were right, which you all know I enjoy proving that we were right. You guys are awesome. I'm really gonna miss you next year. Gotta say, I might get emotional in this little lesson here. Alright, so problem 1, we are given 2 equations, y equals 3x and x plus y equals negative 32. So when we are given these 2 equations, sometimes we really look out and one of those equations is already solved for either x or y. If that happens, like right here, then we already know what y equals. So y actually equals 3 times x. So where y is here, we're going to substitute in 3x. So we can say x plus 3x equals negative 32. Once we have that, we're going to combine our like terms and we get this. And then we're going to simplify and we get that x equals -8. Now we don't yet know what y equals. So we're going to take that -8 that we just figured out and we're going to plug that back into this equation here and say y equals 3x. Well, we know that x equals -8. So we can say that y equals -32. So we just figured out Blue's Clues. We just figured out, oh, I'm sorry, I did that math wrong. 3 times 8 is 24. Alright, so we just figured out what x is, we figured out what y is, and now we are going to check and make sure we were right. When we do that, we're going to go back to our original two equations. So we're going to check both and rewrite them both. So y equals 3x, and then x plus y equals -32. I'm plugging in -8 and -24. And you can see it does work in this equation. And over here, it also works. We're so good. We know that we're right. Okay, that order pair, which if you write it like an order pair, you're going to have -8, -24. That order pair is a solution to this system of equations. We have two equations in this system. -8, -24 works in both of them. It is a solution to both equations. That right there is some pretty cool math. I love it. Try got it one. Solve that system and then come on back. I'll show you how I would do it. We have y equals 2x plus 7 and y equals x minus 1. So in this case, both of our equations are solved for y. What happens there is you can actually take this and substitute it in for y, and then we're going to combine our like terms. So I'm going to get my x's together, get my numbers together, and I get x equals -8. Then I'm going to substitute back. I'm going to go into this one because it's a little more simplified. Notice I always write with the variables and then substitute in, getting y equals -9. So I have my order pair, -8, -9. Now I'm going to check in both of my equations and make sure we got the right solution to our system. So I'm plugging in here for x and y, making sure to put my first number where the x is, my second number where the y is. Now always remember your order of operations. I feel like this is like the greatest hits of your time in my math class. Alright, so we get two true statements. -9 equals -9 and -9 equals -9. Those are true, which means that this was a good solution to our system of equations. Moving on to problem 2. This one you're going to have to do a little bit more math to start with, because neither of these are going to be solved already for x or y. So looking at our two equations, you're going to decide which one looks like it would be easier to go ahead and solve for either x or y. It doesn't matter. I would say if there is a variable without a coefficient, so there's no number in front of it, that's the one you're going to want to solve for. So these both have coefficients. This has a coefficient, but this does not. So I would solve for this y by adding 2x to both sides. I get y equals 2x plus 2. And then, because I know that that equals y, I'm going to go ahead and plug that into my y here. Always go back to the other equation, the one that you haven't used yet. And I'm plugging in 2x plus 2 because I know that's what y equals. And I'm going to distribute, remembering to distribute to both ends. Combining like terms, this really is like the greatest hit of Mrs. Craig's math class. I love it. We have a two-step equation we're going to solve. Divide by 10. And all that work to find out that x equals 1. We know now that x equals 1. So I'm going to go ahead and substitute that in to my other equation so that I can solve for y. And I pretty quickly get that y equals 4. So I think that my order pair is 1, 4. I'm going to substitute that in, that order pair into both of my equations here and hopefully prove that we were right. Always remember, put your second number in for y, first number in for x. And that one works. So 1, 4 is the solution to this equation. Check it out in this equation. And look at that. That's also true. So even though these are different, they're both true statements. 16 equals 16, 2 equals 2. That proves that 1, 4 is a solution to this system. It worked in this equation and it worked in that equation. So this order pair here, 1, 4, is where these two lines would intersect, where they would run into each other on a coordinate system. Go ahead, try got it 2A, and come on back. 2A gives us 4y minus 2x equals 10, and 3y plus x equals 15. So just like I said in problem 2, I'm looking for the variable that doesn't have a coefficient. This x doesn't have a coefficient, so I would go ahead and solve for that. You can solve for anything. You could solve for this y, you can solve for that x, you can solve for that x, that y. That doesn't matter. I'm just telling you the easiest route to go is the variable that doesn't have a coefficient. Just makes that solving a little bit shorter. Actually, a lot of bit shorter. I like that a lot of bit. Alright, so we have found out what x equals, so we can plug that into this other equation. Okay, remember you're going to distribute here, and remember that you're distributing -2 because of that subtraction sign. Negative times a negative would be positive. Negative times a negative would be negative. And that, I think, is a 15. Would be minus 30. And then we combine our like terms, add 30 to both sides, and I get 10y equals 40. Divide by 10, and I get y equals 4. And then I can go ahead and substitute that into my other equation. Notice I just keep going back and forth from equation to equation. Don't really want to stick with the same equation the whole time. So here we find out that x equals 3. So we think our solution is 3, 4. We're going to check that in both of our equations that were in our system. Let's see. Uh-oh. Something happened. Did you see it? Do you know what happened? Oh my goodness, I can't multiply. That's what happened. Well, that's an easy fix because 16 minus 6 is in fact 10. Super. Trying to go too fast. 15 equals 15. So again, even though these are different, that's fine because they're both true. So 10 equals 10, that's true. 15 equals 15, that's true. So we're good. We know that 3, 4 is a solution to this system of equations. Hope you guys are enjoying this, and I can't wait to hear in our Zoom how you did. When you look at problem 3, it's the same kind of thing, except with a word problem. So they give you the word problem, you come up with 2 equations and then solve that system. With problem 4, this is giving us a situation where there are either an infinite number of solutions or no solution. So think back to that first thing that I showed you where we have these 2 lines and at some point they're going to intersect. So we have 2 lines, at some point they're going to intersect. There's a situation where there might not be a solution, so there's no solution. And there's a situation where there's an infinite number of solutions. So the infinite number of solutions one, think back to the last section we did with point slope form. We sometimes had 2 different equations, and I told you they were equivalent. They were the same line. But what that means is we can have 2 different equations that are the same exact line. So if we have that line and then we put another line right over top of it, every single point on that line would be a solution to that system. Every single point, because they overlap at every single point. There's no point where they don't overlap. So given this kind of a situation where you have an equation for a line and then you have another equation for the same line, that is going to have an infinite number of solutions to that system. The situation where there's no solution is where you have 2 parallel lines. So if you have 2 parallel lines, those lines are going on and on and on forever in both directions. But the definition of parallel lines tells us that they're never going to intersect. We can go 10 miles that way. These lines are never going to intersect. They're always going to be this far apart. They're never going to intersect. Because of that, there's no solution to that system. There's no specific order pair that I can put into this equation and this equation that would work because they never overlap. So problem 4 here is about figuring out if it is no solution or an infinite number of solutions. So the one that they give us here, the system, is this. We already have this solved for x, so I would go ahead and put that in for x. And you have to distribute that too. Subtract 8 here. Combine our y's, and we get 0 equals 0. 0 equals 0 is true, isn't it? 0 does equal 0. So that means that this system of equations here, has an infinite number of solutions. Because we came up with a true statement, that means this has an infinite number of solutions. If you look at the next one, next system they give us is y equals 3x minus 11 and y minus 3x equals negative 13. This is already solved for y, so we're going to plug that in for y. If we combine our like terms here, that is going to cancel out and get 0. So we have negative 11 equals negative 13. Well, that is not. That means that there is no solution to this system. So for this system, there is nothing that we can put in there that is going to work in both equations. The reason that is, and the only reason there can possibly be, is that they are parallel lines. So that's it. If you try got it 4, you should find that there are an infinite number of solutions. So it's going to be like this one where you come up with a true statement at the bottom. What I want you guys to do is try a few of these, see how you do. Let's do numbers page 394. I would like you to try 12 and 15, and then 21 and 22. So 4 problems here I want you to try. Make sure you're doing 2 checks for these ones. Check both equations. These ones are where you're going to find probably either an infinite number of solutions or no solutions. So what I want you to do is page 394, 12, 15, 21, and 22. Enjoy doing your last math homework of the year.